This is the second video of Steganography. Hi everyone, this is Irfan again. Previously we saw how bitwise operation works and what steganography is about and how we can change the lowest significant bits into 0 without having any impact on the quality of the image, as like this one, that two lowest significant bits of every byte of this image has changed to 0 without having any impact of it, and then having a space in order to save other messages inside an image. In this video I'm going to show you how you can do the same thing with text messages. Not the same thing, because in the previous one I just showed how bitwise operation works, but in this one we're going to make use of it, which means we have a text message. This is the message, for instance, hello, I'm inside an image, and this is the base image, the image where I want to save this message in and construct this other image. And as you see that the constructed image is exactly the same as this other image. The constructed image, the only difference is that it has just the last bit, the lowest significant bit has changed to 0, and then this message has been changed into binary and has been saved inside it. And then I am going to reconstruct the image as you see here and take it out, extract it from this image that has the encoded message inside it. In order to do so, again, we work with OpenCV, NumPy, and OS. I have written this code almost around 6 months ago, but thanks to Docker strings that I have put for it, I could remember how it works. So today when I had a look at it, I understood that, okay, so this is the way it was working. And some of the methods that you see here, I didn't make use of them because I changed my code a couple of times and I had implemented
better ways. So one of them is this method, message to binary, basically, which would take a message and it would take the binary format of that message and it would return that value. It seems that I didn't implement this one because later on I have implemented another method to decode the encoded message, basically. So decode, by decoding I mean taking the binary value and creating the string value out of it. This method, int content of byte for 2 bytes, basically this one is about taking 2 bytes and saying what the value of that is, which means, for example, you take a string and you say that you take a byte array like this, and you would say that what is the value of that byte array. Or for example, you see something like this, exactly this one, I've written it for this one, and that's why it goes up to 8192, which, if I'm not wrong, is 2 to the power of 14, and it would say, hey, this is 199. So basically, I had implemented it manually rather than using bitwise operation, but the preferred way is using bitwise operation. It was quite a challenge doing things manually and doing this type of calculations myself, which was quite good. So how I took it as a list, how I mapped these values, and then do a dot operation between this list and the positions of the numbers that it is getting. So this so these values and these positions. So that means these values and these positions. Int content of byte would be basically the same thing, but this is only for 1 byte, this is for 2 bytes. Image binary content 0 lowest bit, what it does, it would take an image path and then it would convert the image into grayscale, and then it would calculate the binary value of each image pixel and change the lowest significant bit into 0, and at the end it would return a numpy array of new image content. As you see that it takes the image path, it reads it with OpenCV, it would change it from BGR to gray, so that means it changes the 3 channels to 1 channel, so grayscale is easier to work with grayscale because we don't need to work with 3 channels, we only work with 1 channel, and then it would show it, making an empty list, loop inside our image. This is the width of the image, this is the height of the image, and read those values. The reason I started, read those values, pay attention, the reason I am starting from 2 is because what it would read is this. This is what it returns, and 0b, that means it is dealing with binary values, and then here is the value of the pixel. And I want to say that read everything except for the lowest significant bit, replace that with 0, and then append it to this empty array, empty list, and then reshape it to the original shape of the image, as you see, but with numpy reshape, and then return this value, which would be the 2-dimensional array. Pay attention, what it returns is a 2-dimensional array of strings. It would send you back a string of this format. So all those values are strings inside this 2-dimensional numpy array. So be careful, and that would, if you don't pay attention to that, that would cause a lot of headache. Image binary content, the same concept, looping at the dimensions of the image and reading all the values. This time it's not sending it, it's not changing the lowest significant bit to 0. Convert image binary to integer, it gets a 2-dimensional numpy array and converts every cell from a string. Be careful, remember I told you they were string values. And it would return the equivalent of 0 to 255 integer value. And and then it would return that in the same dimension of the original image. And then embedding text in image, this is one of the methods that does the heavy lifting. It takes a binary text, it takes an input array. First it would make use of the previous method to take the binary content of that input image, flattening it, and then reading the lowest significant bit and replacing it with the value that it is reading from the message, reshaping it to have the shape of the original image, and then and then changing those values into integers, and changing, for example, this value into its equivalent integer value and returning it. Message encoder.
So basically, message encoder is about, here I have a link. So basically I had this question 5-6 months ago, how to decode binary content to original string. So that means if you have a string, you want to put it inside a message, and how to encode it, and then when you get an array of bits, how to decode a message from it. So I asked this question in a Stack Overflow. A great community. It's quite lovely to see that how people support each other, and this nice person has responded back how to do so, and that's why I make use of these two methods: message encoder, message decoder. Message encoder is to encode the message decoder is to decode the message from the original image. So that's it. And then this one is embed encoded messages image. So image path, so it takes the path to our image and it takes the message to encode, and it would make use of all those things that we talked about.
And then one other thing, okay, so a couple of things that I've done here. So in order to put the message inside the image, I would assign the first 2 bytes of the message. So I add another 2 bytes to my message in order to say that how many bits the message has. So for example, look at this. This is this message, hello, I am inside an image. When you encode it, when you take its binary content, it would have 199 bits. So so this is the value, and then I'm going to save this value at the beginning of my image. So I assign the first 14 bytes to that, and I'm saving them into the first 14 bytes. I later use this number in order to read how many values should I read, how many pixels should I read, how many bytes should I read in order to be able to construct my message. And then what else? So the message would be embedded here, so it would do again those loops, and at the end it would return uint8. It would do this conversion to make sure that, because CV2 expects MAT, and basically that is integer, and because we are working with grayscale, that's unsigned integer. The code message from image, what it does is that it would read the image, it would flatten it, and it would read the first 14 bytes, the first 14 pixels, just a least significant bit, to know that how many bytes it needs to read. And after that it would at some point it has this empty list, and then it would start appending them, and after appending those least significant bits for this length 199 number of bits to scan, and assigning it to this message string, it is given to message decoder, and the message is decoded. So, and then here is the body of the main method, in fact. So let's read this message. That is that I that you saw. This is the message that I put inside it. Hello, I am inside an image. And then the image with encoded message, and then that image with encoded message is, as you see here, this is the one, embed encoded message in image. This is the method, this is the return value of that, and here it is being shown, and then the decode message from image would read that one and would change it. So you saw that, how it looks like, how it works, the original image, the image with this text message, hello, I am inside an image, and the length is 199. So for example, if I say hello, Python is
awesome, let's see, for example, how long will it take? This one would be, again, okay, interesting. This one is also 199. Let's say hello, let's say Steganography is awesome. Now let's look at this one. This one is 255 is the length, and you see this image, base image, and here is the one that has constructed it, and here you see that the message has been constructed properly. Hello, Steganography is awesome. So put your questions in the comments. I will try to respond as soon as I can. In the next video I will explain how you can embed an image inside another image. So this is taking one step further of showing how Steganography works. So that's it. I will share also the GitHub repo, so you can have a look at the GitHub repo, and in the next video you will see how to hide this image inside this image.